Okay, that last part was a lot of work. Thankfully, we won't need to find every one of those for this next part. So for the determinant of a square matrix, we already did a 2 by 2 matrix, but now we're going to learn something that can apply to 2 by 2s, but also 3 by 3s, 4 by 4s, whatever. So if A is a square matrix of order 2 by 2 or greater, the determinant of A is the sum of the entries in any row or any column of A multiplied by the respective cofactors. For example, for instance, if you want to look at matrix A, say you just want to work across row 1, so it'd be like the first term in row 1, column 1 times its cofactor plus row 1, column 2 times its cofactor plus etc., 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 all the way until you get to the end of the row. So by applying this definition to a determinant, or to find a determinant, is called expanding the cofactors. So for this specific example here, we're asked to use this for a 2 by 2 matrix. We're asked to do the determinant of A. We already know how to do this, but kind of applying the same rule. Let's just work across that first row. So I'm just going to highlight that first row. We're going to focus on that. So we're going to do the first term in that first row, A sub 1, 1, times its cofactor. So it's going to be C sub 1, 1, plus A sub 1, 2, the term in row 1, column 2, times its cofactor. Now, the term in A sub 1, 1, the first row, first column is just, well, A sub 1. Now, the cofactor for row 1, column 1, it's as if we cross off row 1 and column 1, and we're left with not really much of a matrix. We're just left with that B sub 2. So it's going to be A sub 1 times B sub 2. Then we're going to say plus, and let me clear out that stuff that I just wrote there. Now we're focusing on the first row, second term. That's going to be B sub 1 times its cofactor. So it's as if we cross off row 1 and column 2, and we're left with A sub 2. But since it's, and this is something I kind of glossed over, C sub 1, 1 and A sub 1, 2. 1, 1 is an even, so that's going to be the same sign. So we didn't need to worry about changing it. But 1, 2 is an odd, so it's going to be the opposite sign. So it's going to be the opposite of this minor here, which is just, well, A sub 2. So we're going to make it negative A sub 2. Cleaning this up a little bit, we got A sub 1 times B sub 2 minus, since it's positive times a negative, I'm just going to put it in standard form, A sub 2 times B sub 1, which is really that original determinant that we learned earlier. Kind of applying it to this example down here, the final couple examples down here, we have the formula for a 2 by 2 matrix. We're going to try to apply it to this 3 by 3 matrix. Now we get to pick whatever row or whatever column we want. I would encourage you to pick a row or column that has a 0 in it, because it's going to make things nice and easy. Let's just, for simplicity's sake, let's just focus on row 1 and work our way across there. So the determinant of matrix A is going to be A sub 1, 1, whatever that first term is, times its cofactor, plus A sub 1, 2 times its cofactor, plus the last term in that row, A sub 1, 3 times its cofactor. Now, A sub 1, 1, that is 0. The cofactor is as if we cross off row 1 and column 1, so we're just left with that matrix of negative 1, 2, 0, 1. We'll clean that up in a second. Sorry, let me erase some of this. Plus, now in this case, we already know 1, 2 is going to have the opposite sign, so I'm just going to make it a minus right off the bat. So our term, A sub 1, 2, is going to be 2 times its cofactor, so it's as if we cross off row 1, column 2. We're left with 3, 2, 4, 1. Let me clear this off again. And then 1, 3, A sub 1, 3, that's an even term, so we'll do plus 1, 3 is 1, that one right there. And we cross off row 1 and column 3, and again, the cofactor is going to stay with the same sign, so whatever we end up with. So it's going to be 1 times 3, negative 1, 4, 0. So we have to find 3 different cofactors. Now from there, we got to go through and simplify each of these. So we actually have to do the determinants of these 3 matrices. So in order to do that, we're going to do 0 times whatever this determinant is. Well, whatever this determinant is times 0 is just going to be 0, so that's not too bad. So we're going to do minus 2, and then again, we're going to multiply it by like the determinant of that matrix. So it's going to be 3 times 1 minus the other diagonal, 4 times 2. And then the last one is going to be plus that 1. That was our term in A sub 1, 3, row 1, column 3. So we're going to do that diagonal again. So we got 3 times 0 minus the other diagonal, 4 times negative 1. Sorry, overused parentheses there. Okay, cleaning this up just a little bit more. We got 0 minus 2, and then in parentheses we got 3 minus 8, so that gives us negative 5. Then plus, we got 1 times, this is 0 minus negative 4, so plus 4, so 1 times 4. So we got negative 2 times negative 5, that's 10, plus 4 gives us 14. So we can say the determinant of matrix A is 14. For this last matrix, I'm going to give you a hint. I would always choose a row or a column that has a lot of zeros in it. So like looking at that first row, it has 2 zeros in it. It's going to make things nice and easy. So I'm going to say the determinant of matrix B. Let's just start off with, I guess if we're using B, I'll do B sub 1, 1 times its cofactor plus B sub 1, 2 times its cofactor plus B sub 1, 3 times its cofactor. So B sub 1, 1, that's row 1, position 1, so it's going to be a positive sign. Sorry, row 1, column 1. So essentially we're going to kind of ignore row 1 and column 1, and we're left with our B sub 1, 1, that term is 2, and then the matrix that we have to do the determinant of is what's left there. We got the negative 2, 1, 5, 0. Let me get rid of those a second. Now B sub 1, 2, that's an odd position, so it's going to have an opposite sign. B sub 1, 2 is going to be 0 times, well, you might see where this is going, but I'm going to write out the matrix anyways. So the matrix would be, we cross off row 1, column 2. So the matrix, the determinant that we'd have to take would be 3, 1, negative 1, 0. And then finally, B sub 1, 3, that's row 1, column 3, so it's an even position, so it's going to be a positive. And the value there, that 0, we'll put there. And then the matrix that's left after we cross off row 1, column 3 is 3, negative 2, negative 1, 5. Now this is, again, is going to work out pretty nicely because that cancels out and that cancels out. We actually don't really need to calculate those determinants because it's 0 times whatever, so who cares? It cancels out. So we really just have to do this last one. So we got 2 times, and then again, remember the diagonals. So we got negative 2 times 0 minus the other diagonal of 5 times 1. And again, everything else canceled out. So we have 2 times, we got 0 here, and then minus 5, so 2 times negative 5, which gives us a grand total of negative 10. So we'd say the determinant of, determinant of matrix B is negative 10.